Hey folks. Well, we've gone through bubble sort and just some basic sorting and some searching and binary search for when we know an array is sorted. But I want to take a look at a few more sorting algorithms. So the first couple that we look at are going to be around the same order of efficiency as bubble sort for the most part. But we'll look at some places where they might be interesting anyways. So we're going to take a look at one called insertion sort. And this basically builds a sort of a sorted portion of the array. Based on the elements that we've seen so far in the array, this portion will be sorted. So we might look at the first element of the array and it's sorted by itself. And then we'll grab a second element and have the two of them together sorted. And then grab a third element and the three of them together sorted. So we'll just build it up one piece at a time. And then another one, selection sort, where we'll say, well, I'm still going to build it up kind of in sorted order, one piece at a time, but what I'm going to do is look at the first position of the array and out of everything that's out there, grab the smallest thing in the entire array and put it in that first position because in the end, that's where it belongs. Then I'll move on to the next position and say, okay, out of everything that's left in the array, grab the next smallest thing and put it in this position because that's where it belongs. And we'll just proceed through the entire array that way. So you can see kind of a relationship in the logic between these two different sorting techniques. And we'll have a look at the algorithms for both and maybe look at a bit of code for both. So we'll do insertion sort first. And again, the idea is we've got this array of a bunch of elements that aren't sorted or that we don't know are sorted. And so we're just going to build up a sorted portion of the array going through one element at a time. So for each new element that we look at, we'll move it into its correct spot out of the things we've looked at so far. So, when we're looking at the fourth element, we're going to be moving it into, or we're going to be creating a sorted portion of the array, those four elements. And by the time we get to the end of the array, we'll have the entire thing sorted is the idea. So we'll run through a couple of examples here to get a bit of a feel for how the algorithm works, and then maybe get into some code. So again, suppose we had an array of values and they're just in some random scrambled order. So we've got, 17, 3, 11, 9, 6, 10, and we want to get them into sorted order increasing or non-decreasing. So what we'll do at first is we'll just look at that first element. Well, 17 by itself is sorted, right? I mean, if you've only got one element, it's sorted. So then we'll move on to the next element and say, okay, now we've got a 3. So now I want to get 3 and 17 sorted together. So obviously the 3 belongs before the 17. Right? So we'll grab that 3, move it into its correct spot before 17. And so now we've got this kind of sorted portion at the beginning that's the 3 and the 17, and this unsorted stuff still to come. And we'll just keep pulling things from that unsorted mess and moving it into the right spot in the sorted section. Right? So next, we'll go through and say, okay, well, the next thing we've got to deal with is 11, and so we'll move it into its correct spot in the front half here. So it belongs between the 3 and the 17, obviously, so we wind up with a 3, 11, and 17, and then we've still got this other stuff to do. And so again, we just continue on, right? Grab the 9, move it into its correct spot. Grab the 6, move it into its correct spot. Grab the 10, move it into its correct spot. And eventually, once we've done the last thing, we're done. So it's just a matter of, it's easy enough to set up a loop that says, okay, well, until we reach the end, we've got to keep doing this. But we need a loop kind of on the inside of each pass, if you like, that says, okay, well, how do I take this current element that I'm inserting and move it into its correct spot in the rest of the array? And so what we're going to try doing is just saying, okay, well, if I take it and compare it with the thing before it, if it's bigger, then it stays where it is. So if this was a 20, let's say, it would stay right where it is. But if it's less than the element that I'm looking at right now, then I can swap the two of them. Move the 10 back and the 17 up. And then continue on, compare 10 with the thing before it and see if I need to swap it further down or not. Compare 10 with the thing before it and see if I need to swap it further down or not. So that's the approach that we're going to work with. So we describe this kind of an algorithm as working in place. That is, we don't need a secondary array to move data into. We're just going to be kind of keeping the array values in the same array, just moving them around as we go. So again, we're going to follow this idea of taking the element that we have to move, let's say the 10, and just swapping it backwards through the sorted portion until it reaches its correct spot. Right? So again, let's say if we had our 3, 11, 17, and we were doing the 9, then we'll just say, okay, well, where does the 9 belong in this? Is it less than the 17? Yes, it is. Swap the two of them. Is the 9 less than the 11? Yes, it is. Swap the two of them. And so we just move the 9 backwards until we eventually get what we want. All right, so that's the idea. We just need to turn this into an algorithm, right? Write up a sort of an outline of how this is going to work, and then turn that into code. So we'll try the algorithm first. So our insertion sort algorithm will have current pause is keeping track of where we are in the array, sort of what portion has been sorted and what hasn't so far. So position 0 in the array, that one element by itself, is always sorted. So I'm going to start this off at 1 and say this is the position of the next thing that has to find its right place in the list. So current pause is the thing that we're eventually going to be moving backwards through the sorted portion. And so while this is less than n, I've still got work to do. I've still got at least one element to move to its correct position. So this outer loop is the one that keeps us going until we're done. And then inside, I'm going to have this second position that says, okay, I got to keep track of where this thing is as I swap it backwards and backwards and backwards and backwards through the array until it finds its right spot. So this index is going to be where that value is right now as I move it back towards its correct position. So again, in the beginning, it's wherever that element happens to be sitting at the moment. And then we're going to say, well, while there are still things before us, and this thing that I'm trying to move is bigger than, or is smaller than the thing before it, I want to keep moving backwards. So let's say if I've got the 9 and I'm trying to move it backwards and there's an 11 before it, I have to move it. So while there's still space to go, still space before me, and while I'm smaller than the thing before me, swap the element that I'm moving with the thing before it, and then move on, right? Continue on down the chain to see if there are still other bigger things before me that I have to move past. And so once I've done this, I will have moved that current element back to its correct spot. And so we can move on to the next thing in the array and see where it belongs. So that's our algorithm. We just need to turn it into code. So let's see if we can give that a try here. All right, so what we've got here is our insert code. As you noticed in there, we had a swap routine that we were going to make use of. So I've got a simple swap function. I'm just going to assume we've got a bunch of doubles, or a bunch of floats rather, as our numbers here. So usual swap, exchange the values of x and y. I will have a main routine down here at the bottom where we just give it a quick try. We'll create an array of kind of 16 randomly scrambled or more or less randomly scrambled values. We'll call our insertion sort and see if it actually gives us the values back in the correct order. So that'll just be for testing purposes though. So for our insertion sort, I'm going to throw a little bit of error checking in. If they pass us a bad pointer, I'll bail out. And if they ask us to sort, one element or 0 elements, then I'm going to say, well, it's sorted. Never mind, I'm done. So we'll have those couple of base cases to deal with. But in general, what I want to do, so this is kind of like my current index in that, or current position in that previous slide, where I'm saying, well, P will be keeping track of the next position, the next element that I'm going to have to move into its right position. So I'm going to start it off at 1. Right? I'm going to assume that whatever's in 0 starts off sorted by itself. And I'm going to keep going until I'm done, until I've sorted everything in the array. And then I'm going to say, okay, well, yeah, I switched my variable names here, didn't I? So this time around, we're going to use current position as the current spot for the thing that we're moving. And again, I'm starting it off at our current position, and I'm going to say, okay, well, there's still things before me, and while or the array current pos is the thing I'm moving, while it's still smaller than the thing before it, swap the two of them so it moves closer to its correct position in the array and move down one step. All right, and so this is just going through exactly that cycle. All right, so hopefully, if we give this a whirl, and we'll try running this and see if we actually get, hey, we got sorted values, yay. So if you want to have a look at the sample code for this one, where did I put it? If you go back to the main page that's got all of the links for the video content on there, where was our simple sort? It was in the first week of February. There's sample code available there. So there's a link where you can grab that insert sort, and it'll also have the select sort that we're just about to do here. All right. So for the other sorting algorithm, oh, actually, that's right. I was going to mention a couple of places where insertion sort might actually be useful. So it's no more efficient than bubble sort, but it can be handy. Let's suppose that we're gradually building up data over the course of time. So the user adds one or two new data items and then does a bunch of stuff with the sorted array, with the sorted data that they've got so far, and then adds a couple more items and does stuff with that sorted portion. Well, we need to keep that data sorted because they're doing things with it in the interim, assuming that it's already sorted. So we want to keep the data sorted, but we don't want to go through all the hassle of doing a complete resort as if the array was completely scrambled every time we want to insert one new thing. So using this kind of an idea, our insertion sort, we can say, okay, well, we'll grab one new item when they give it to us, and we'll use the sort of technique that we did just a moment ago to insert by just putting that new item at the end of the array and moving it backwards until it finds its correct position. So essentially, when the user wants to do an insert, we just do that inner loop portion to go through. Okay, well, you've got one more item to add and you need it put into our sorted stuff. We'll put it at the end and swap it backwards until it finds its correct spot. So this can be kind of an effective way to work with data where you're just getting it in little bits and pieces and you want to work with the sorted portions in between. All right, on to our selection sort. And so again, the idea for this one was to say, okay, I've got this big scrambled array. What I'm going to do is look at position 0 and figure out what belongs there. And I'm going to move on and look at position 1 and figure out what belongs there. Position 2, what belongs there. So at each point, I'm looking through all of the rest of the kind of unchosen portion of the array, finding the smallest thing out there, and that's what belongs in my current array position. So we just repeatedly go through picking the smallest out of what's left and putting that in our current position. And again, the way we can get it into the current position is by just swapping it with whatever's there now. Right? Whatever's there now is bigger than whatever we're putting here, so we can just swap it out into the unsorted portion somewhere, and we'll pick it later when its turn comes along. So again, typical selection sort example, if we use the same sort of idea where we've got a bunch of scrambled data, then I'm going to start off at the beginning and say, well, I need to know what goes into this position 0. So out of the whole array, I'm going to look through all of this and find the smallest thing out there and remember where it is. So I go through this, and it's not said 17 is the smallest so far. 3 smaller, 3 still the smallest. So eventually I say, okay, smallest thing I found was 3. We'll swap it into that front position. So I wind up with the 317 and then all the rest of this stuff. So now this next time around, I want to find the smallest out of what's left and bring it into that next position. So out of everything that's left, the 6 is the smallest, so I'll swap it and the 17. And so now I've got the 3 and the 6 that are in their right spots, and I've got a bunch of other stuff out there. So out of what's left, I want to go through and say, well, what's the smallest thing that's left? It's going to be the 9, so we'll swap it with the 11 in this case. and we get our 369, and then a bunch of stuff. And you just keep going, right? Out of what's left, the 10 is going to be the smallest, so it's going to move in front and swap with the 11. And then out of what's left, the 11 is the smallest, so it's going to move in front and swap with the 17. And you just gradually build up until you're done, you reach the end of the array. So similar sort of idea in terms of an algorithm. We're going to have one thing that's keeping track of the position that we're trying to fill. And so we'll have this one outer loop that says, okay, well, while I've still got stuff to fill, or while I've still got positions to fill, keep going through. And then this inner loop that's going to go through and say, okay, well, I have to, out of the stuff that's left, out of this unsorted mess that I haven't dealt with yet, I have to find the smallest thing. So what I'm going to do is just go through that portion that's left, one element at a time, remembering what's the smallest thing I've seen so far, and where was it. So I'll keep track of what's the smallest value I've seen, and in the beginning it's just going to be the one that I'm sitting on right now, and where did I find it, so which position was it in. And I'll just go through the array one element at a time until I hit the end, and if what's in the current position is smaller than the smallest thing I've seen so far, then I say, okay, well, now this is the new smallest thing I've seen so far. So I update smallest with that new value, and I update the small position with where I found it, and I just keep on going. By the time I get to the end of the array, these two things tell me the smallest value I found and where it is. And so then what I'll do is just swap whatever's currently sitting in that position I'm trying to fill with that small value that I found out there somewhere. So the thing I'm sitting on now moves into the unsorted portion, and the thing that I want here gets swapped in. And I just keep bumping up my position as I work my way through this. So again, relatively straightforward algorithm. And we can take a look at the code for this. If I can get my windows juggled here. So if we have a look at our select sort, it's again doing the same sort of thing as we ran through with the insertion sort, where we've got a swap routine we're making use of and a main routine down at the bottom here that's just trying it out to make sure it actually works. And we'll have the same sort of error checking, right? Make sure that the pointer that they gave us for the array isn't null. Make sure that they actually asked us to sort, 2 or more items, otherwise we're just done. But the bulk of what we're interested in is this loop that's saying, okay, well, current will be the position that I'm trying to fill right now. So we'll go from 0 to the second to last position. Right? If I've got 12 positions, if I've got the first 11 things in their right spot, well, then the 12th thing has to be in its correct spot by default. So we'll go through picking what belongs in the current position, and the way we'll do that each time is to find the smallest thing that's out of what's left and swap it into that position. So again, the smallest will be the smallest value I've seen in this kind of unsorted portion, and the small pause will be where I found it. And so we'll just say, okay, well, the smallest thing I've seen so far is the thing I'm sitting on now, and it's wherever I'm sitting, and I'll just go through everything else that's out there, and if I find something new smaller than that, then I'll say, my new smallest is this, its position was here, and when I get to the end, I'll say, okay, let's move it into the position it belongs in. So again, current being where it belongs, small pause being where it was, just swap the two of them. And again, this should hopefully work out. So if we try our select sort, okay. So again, we can come up with some reasonably simple sorting algorithms. Again, these aren't terribly efficient. As you start getting into larger values of n, you are going to run into some some distinct problems with how long this is going to take to sort, but they are quick and useful sorting algorithms to put together. Next time around, we'll get into some more efficient, more effective algorithms. So next time, where we're going to go is looking at, I believe, merge sort, which is a nice and handy one that we'll get into, and then quick sort. And again, we've got links for a sample code if you want to have a look at the actual code for this. You know, frantically trying to read the code that I've got written on this as you're watching the video here. All right, we'll pick things up next time.